So hi everyone, welcome back to my channel. In this video, we'll be dealing with a new problem statement that is repeated and missing element. So it's an intermediate type of array data structure question. Firstly, we'll be doing the brute force method, that is the time complexity would be big O of n square. After that, we will optimize it to a time complexity of big O of n and space complexity of big O of n. So let's get started and explore the problem statement. This is our problem statement. It's written that given an integer array of length n which are having element ranging from 1 to n. This array might be sorted or might not be sorted. And one twist in this array would be one element in this array is repeated two times. Let's understand this with the help of an example. See, we are having an array of size 7 having elements from 1 to 7, but it is having 2 repeated 2 times, and in place of 3 the 2 has acquired the place of 3, so the output repeated 2 missing 3. Similarly, there's a mistake over here. Wait. In this array, we are having 5 as our repeated element and 4 is missing. So this is the thing that we need to do. Firstly, we need to check the given array and come up with an output of repeated and missing. The first solution that comes to our mind is, so firstly we'll be doing it with a brute force solution to reach the output anyhow. So let's understand the logic behind it. So this is the logic behind our brute force technique. First of all, we'll be having an outer loop with variable I, which would be ranging from 1 to n. Inside this outer for loop, we'll be having a counter variable of int data type with initial value as 0. After this, an inner for loop which would be ranging from 0 to n minus 1 and having variable j. And now a condition would be there inside the inner for loop which would check if the element at j index in the given array is equal to I, means the value of outer for loop, then c plus plus, means the value of our counter variable would increase by 1. And after this inner for loop terminates, a checking would be done. If c equals to 0, means the number which we were finding is not there in our given array, then we would be storing it in the missing variable. Over here you can see that I have already declared it in the code, missing variable, and there would be a repeating variable. It would be better if I write it as -1, initial values at -1. So here it is. If c equals to 0, means the value of I, the number which we were finding, hasn't occurred even a single time in our given array. So that's why the value of counter variables, means c, is 0. Then missing would be allotted with the value I, which is the missing number. Further, if c equals to 2, it means the number which we were finding has occurred 2 times. That's why the value of our counter variable is 2 this time. So we would be storing it in the repeated variable. So the time complexity of this entire operation would be big O of n square. Why? As you can see, there are two loops, one inside the other. So it will have big O of n square time complexity. The space complexity is big O of 1 because we are not using any sort of extra space in this. Alright. So over here I have applied the exact same logic that we have discussed just now. In the end, I have printed the repeating and missing value. So now let's get started. I'll be running the code. See, it is showing me the repeating value as 5 and missing value as 4. So this is my brute force solution. When we'll be sitting in an interview, the interviewer would ask us to optimize this code because the time complexity of O n square, big O of n square, is not very efficient. So now let's check out how we'll be using an optimized logic for this problem statement. So this is our optimized logic. In this logic, what I have done, firstly, I have defined an array with length equal to the length of our given array plus 1. As you can see in the code, I have defined it over here. This is my given array, and similar to the previous question, I have taken a repeating and missing variable of int type like this. Below that, I have defined a for loop which would be running from 0 till n minus 1, where n is the length of our given array. Inside this for loop, we'll be taking index as our given array First of all, we'll be extracting values from our given array at each index, and after that, we'll be using the extracted value as the index of our new array and increment that by 1. This is the for loop for the same. After this for loop ends, after this for loop ends, we need to iterate our new array in order to come out with a conclusion. If an index in our new array has been incremented by 2, means it has been incremented 2 times, so the repeated variable will be assigned with the value I. Else if, this is else if the index value hasn't occurred even a single time in our given array, it means that its value is going to be 0. Then we'll be assigning missing as I, right? This is the for loop for the same working of that, and at the end I'll be printing the repeating and the missing value. So the time complexity for the entire algorithm is big O of n, and the space complexity is also big O of n. Time complexity is big O of n because there are no nested loops, two loops, and they are not nested with each other. And the space complexity is going to be big O of n because we are using an extra space of our for our new array. So now I'll be running this code on code editor. So I have written down the exact same code of our optimized logic. Now I'll be running it. Again, it is producing the correct output, repeating as 5, missing as 4. So this was our optimized approach. But can we optimize our logic even further? So in the next video, I'll be solving this problem with even more optimized solution. So see you in the next video.